here and it's working.
Okay, I think we should begin, because if we want to ask the last one to take a seat, it will take too much time. Hello, Marcin Switoniak. We wait for your presentation and we hope that we can discuss this also. And it's on the diverseness of soil units according to the WRB, developed as a result of truncation in northern Poland. Okay, please go ahead.
Thank you very much, Karl, for this invitation. Ladies and gentlemen, I'm from Poland, also like a big group of the participants here. And today I'm really glad that I can make this presentation in the normal, not the distant mode. Today I will talk about another type of the changes of the soil cover in young glaciation areas. If I am talking about the young glaciation, I'm thinking about the morainic areas which was covered by the last glaciation. So it means that for 15,000 of the years, they're of course not glaciated now, but they still are full of the features which are connected with the last glaciation. So that's why I'm calling it the young glaciation area. And yesterday, Marcin showed us beautiful examples of the transformation of the soils due to the, let's say, changing of the water in the soils which are hydromorphic. And today I will talk more about the erosion, another problem that we have in our region. If you would see on the general map of the world, of course, the soil erosion is not the main, let's say the Poland is not the area which is covered by the main transformation of the soil erosion. There are many other countries and regions which has more severe problems, like this one, for example, where the soil cover is almost totally eroded. But also in Poland, you can see that the north part and the south part can be somehow transformed by the soil erosion. So it means that the soil erosion is stronger, more faster than the soil processes. So it means that some soils, a lot of soils can be shallower due to the erosion. In the south part, maybe I will show it on this map. This is the models of the potential and actual water erosion in Poland. So you can see the actual erosion. It's of course the biggest one. It's in the mountains in the Poland and also in the areas of the less deposits, but also in the north part, which was covered, as I told you, by the last glaciation. So it means that we still have here the hills, the depressions, a lot of slopes, and it's highly under the agriculture uses. We have this weak or medium erosion in general. This is also our voivodeships, so it's the administrative unit that we have in Poland. The Toruń, my city, is located here, but you can see that mostly on the slopes of the rivers, on the subglacial channels, and also in the morainic areas, we have a lot of potential erosional processes. This photo, for example, was taken 3 or 4 years ago after just one of the rain that we had in the Poland, and this one was in the last year. It was just one night with the heavy rain, and you can see that we have 10 centimeters of fresh colluvium which came down through the slope, especially now if we have these corn plantations, it's very rapidly. So it's just to show you that we have a lot of problems with the soil erosion. If you are walking through our landscapes, especially in the morainic landscapes, you can see beautiful changes in the colors. These beautiful changes in the colors in the uppermost horizon, plowing horizon, are connected, of course, with the topography. You can see that in the uppermost part of the hills, it's the very light brown colors. There is the brown on the slopes, on the upper part slopes, then the gray, and the very dark gray in the depressions. And it's connected also with the erosion. I will show you in the next slides. This is the piece of the ortho photo map, and you can also see the beautiful changes of the erosion. This one is like, I don't know, 200 meters from here to here. All of these very light areas, which are, let's say, the oval in the, or rounded in the shape, there are the hills, which are with the soils, which have very light in brown colors of the surface horizons. Then we have the brownish rings around of them, and it's the upper part of the slopes. And then in the lower part of the slopes, we have light green, or even in depression, very dark gray, sorry, not green, but gray colors. Of course, it is connected with the changes of the soils itself. And you can see that here we have the eroded soils, here a little less eroded, and here's the accumulation of the colluvial material, sometimes on the materials, for example, that yesterday Marcin showed us. So the hydromorphic soils with very well developed humus or even organic horizon. And it's strictly connected with these colors of the surface horizon and with the topography. Of course, now we know that it's mostly connected, if you are talking about the upper part of the hills and the summits of the hills of this morainic materials, that it's connected with the erosion of the soils, which previously were the Luvi soils, were the Reti soils, so the soils with beautiful alluvial zone, and of course the illuvial horizon, which was primary before the erosion started on the depth of the 80 centimeters, 100, something like this in general. And of course, partially it was during the time eroded. What is the time of this erosion and the ratio? Of course, in the another slopes, in the different slopes, it can be differ. But in general, in our area, the cultivation started many hundreds years ago, sometimes even in the before the medieval times. So every year it's just, you know, sometimes 1 millimeter, sometimes 2-3 millimeters per year, it's going down. So at the end, now on different slopes, we have soils like this one. So we have the argic horizon just under the humus horizon, and these soils, maybe this, so it's more where this argic horizon is plowed into the humus horizon. We can visible them on the surface as these brownish rings. And the soils which are totally eroded, because they contain the secondary carbonates, which primary they were moved down and accumulated with the percolated water in the depth like 100, 120, 150 centimeters. Now they are on the top of the soils, even in the humus horizons. So in general, this totally eroded, maybe not totally, but very strongly eroded soils look like this. That we have only the weakly developed humus horizon and the parent material, or some kind of the B horizon with the secondary carbonates, which are here. And yeah, they are very clearly visible on the orthophoto maps, of course, but they are not so homogeneous. Of course, they have only two horizons. This is the common feature of them. And under this, they have more or less bigger or smaller amount of these secondary carbonates. But sometimes they have also some glaic properties or stagnant properties that are visible on this right side. Sometimes they're more dry without these features. Sometimes these humus horizons are well developed. Sometimes are very, very weakly developed. So we decided to make the investigation of them. So check the method of how we can easily find these soils in the field, and you will see that it's very simple method. It's even my daughter, which is 7 years old, she can make it without any problems. Then estimate what is the share of this totally eroded soils, and then this is the okay, and also the determination of the main properties of the soils, and thanks for that also make the estimate the systematic position of them according to WRB. On this slide, you can see that sometimes it's so clearly visible in the field. Yes, this is covered by the trees, by the forest. Here is beautiful developed Luvi soil, and here is just totally eroded soil to the parent material. Okay, today I will show you only the soils which were located in the Chełmża commune, in a small administrative unit. It has 180 square kilometers. Mostly, it's covered by the glacial morainic plateaus. Some of them are more, let's say, flat. Some, like this light brown, it's more undulating or even the hilly morainic plateau. In the central part of this area. We have also the subglacial or the tunnel valley, which was developed under the glacier. You can see that the topography of this area is really, let's say, intensive. So it means that it's not flat. We have a lot of hills, a lot of depressions, a lot of slopes here. So it's very good to have the studies about the soil erosion in such areas. This is just the general view of the soil cover, but this map was made from the soil agricultural maps. So not according to our investigation. What I would like to say that mostly it's covered by the luvisols and retisols in the maps which were made in the 60s. Sometimes we have also these brown areas, like here you can see this dark brown, by the soils which were called in these times on these maps as cambisols. But please remember that now we know that they are eroded luvisols, not cambisols. And also this black one that you can see here, there are soils which are in the depressions with the thick humus horizon, like a molic or chernik horizon, and with the glaic properties. So it's, for example, the chernik glacials, molic glacials sometimes, or even the glaic chernozems. Like here you can see, this is the area of this, let's say, luvisols, eroded or not. Here is this chernik glacials. And the methods that we use to find these eroded soils, it's very, very simple. It's enough to have the orthophoto maps with the areas which were just plowed, so without any cover of the plants. And you can see this beautiful brownish rings around. This is the eroded luvisols with the BT horizon on the top. And inside of this, let's say that on the top of the hills, there are areas with the soils with very, very light brown colors in the arable horizon. And this is this eroded soils. In general, we can divide them into two types. One type is in the a little bigger hills, which are with the good drainage in the soil. Sometimes it's smaller hills, which are, for example, like this, surrounded by the very black in color soils on this orthophoto maps. And they have the not so good drainage with a lot of features which is connected with the stagnation of the even ground water. So this method is really easy and how many contours with this we found in this area? It was more this totally, let's say totally or strongly eroded with this very light color on the top. 700 contours. Unfortunately, we could make it only in the 30% of this country because 70% was covered by some crops or other things, so we couldn't make this investigation in these places. But in general, they covers this contours 1% of areas where they could be estimated. So we can say that this eroded, strongly eroded soils, they cover 1% of the whole area. Another one which is very important is that it works. So first we found it on the orthophoto map, then we go to the field, and then we check, is it true or not? And we made a lot of drillings, like, I don't know, I don't remember now, but 90 or 100 of them. And 96% our estimated was good done. So we can say that it's very, very easy method to find this soil. Maybe this one, it's not so important here. In general, we can see that all of this area is strongly transformed by the erosion. Of course, in some areas, these totally eroded paddons had more than 1%. In the very undulating, they could even cover more than 5, 7, 10% on some sub areas. But in general, it was 1%. And what we found according to the main properties. As I told you, mostly the weakly developed or not weakly, the humus horizon and the parent material with secondary carbonates, sometimes with the glaic properties and others. This is just the which laboratory test we made, so it's very standard analysis. We also, of course, checked all of the diagnostic criteria of the color, of the amount of the humus, organic carbon in the horizon before we made the soil classification. And what we found. You can see on this graph the main features of this soil. First is what was the amount of the secondary carbonates. You can see that this, let's say, line divided into two groups. This group is where the secondary carbonates were enough to say that we have the calcic horizon even. This group is with the protocalcic, sometimes even in some cases just the calcaric, but still with some carbonates. Another, let's say, two groups is this one is connected with the soils which are more or less dry without big influence of this groundwater or stagnation of the water. Here is the group of the soils which have this influence. And the last, which is important, is the amount of organic carbon and development of the humus horizon. Is it strong enough to be molik or chernik in this part? And this part in the left side, is it not enough? So it's just, for example, the ochric. Ochric as a qualifier in the WRB. We can see that the biggest group is this one, but I will show you all of them. So the 73%, this subgroup, it's a soils which we had to classify as eregosols, but with protocalcic qualifier. Unfortunately, this protocalcic is in the supplementary qualifiers, so we couldn't express it in the name of the soil. So this utric, regosols, arid, protocalcic, loamic, and ochric. So you can see that if we have such soils, we are almost sure in Poland that it's very eroded soil in most of the cases, of course. Another one, maybe it's not so common, but we found also two examples in this area. But in my, let's say, in the past, I found more of them in the Poland. There are soils which have enough, more than 15% of the calcium carbonate, with a lot of course, the secondary carbonates in this second horizon. So they have to be classified as calcisols. So please remember that also in Poland, and I know that it's the same situation in the Lithuania, in Germany, in the Czech Republic, and other countries in our region, that we can find the calcisols. And privately, for me, it's not a problem. Some pedologists are not so happy because the calcisol are traditionally connected with the arid soils, with the accumulation of the secondary carbonates because of this going up of the water, yes, and precipitation of these carbonates. But in our cases, it's because it's the excavation of the horizon, of calcic horizon, which were on the depth of 1 meter, 1.5 meter previously before the erosion started. So please remember that we also have this calcisol. Sometimes in some places, in the places where the erosion in the last year was stopped because of the, for example, putting on the top of the soil the grasses, or as you can see here, by the strip till, which is more and more common in the Poland. So this ochric, let's say, or not horizon, but this humus horizon, which was only ochric, they were developed again into the molik. So now we have the situations, also only two cases, or even one case, that we have the molik horizon here on calcic horizons, so or protocalcic. So we have, of course, the castanozems also in Poland. And I think that amount of castanozems will grow and grow if we are talking about the soil classification, because this tillage, not no tillage or reduced tillage practices are more and more common, and it's really stopped erosion and makes, again, the development of the humus horizons. In my case, it's also very good pedo indicator of the changes, this WRB position of this soil. So you can see, yes, the example of this soil is still plowed, and amount of this, for example, the organic carbon is only 0.5%. You can see the color is almost like just the glacial till, and here we have the almost 2 times more after 15 years of not plowing, just changing into the strip till. Okay, of course, some of the soils were also connected with the high influence of the ground or stagnation of the water. Some of them we had to classify as a molik glacials. In general, they have better developed the humus horizon because the soil erosion is not so fast in these places. Sometimes they had to be classified also as stagnosols, because please remember that they are all still on the top of small hills. Sometimes it's not the influence of the groundwater, but the stagnation of the water in this material. And if we have no other diagnostic horizon, so they had to be classified as this. Okay, so this is the end, the main conclusion. Maybe I won't read this because I already told everything. Please remember that because of the soil erosion, we have a lot of regosols, protocalcic, calcaric regosols, but also in some cases the calcisols, which can be the pedo-indicators of these processes in this case. And if the erosion is stopped and the area, sometimes due to the high inclination of the slope, is changed into the, for example, the pasture, and there is now it's covered by the grass. And sometimes because the strip till, even more often it is this situation, it is changed again into the, not again, but it's development of the humus horizon, and in the classification it goes, the soils will go to the castanozems, and we also find, for me it's not a problem, but for many people it is. So maybe this is the main conclusion that it's from this presentation. And a lot of such situations you can find in our soil sequences atlases that we made. Now we will be the 5th edition in next month. I think that it will be ready. You can find there a lot, all of these catinas, very good described. Of course, a lot of articles about this. And thank you very much. It's everything.
Thanks a lot, Marcin. We run out of time, but one question I would allow. Where is it? Sergey. Give him the mic.
Then I will try to speak as loud as possible. Marcin, thank you very much for this presentation. Of course, my question goes to the calcic qualifier and to the fact that you define castanozems and calcisols in the Baltic area, which is for traditional approach is something really shocking.
Yes, I know. That's why I wanted to show it.
Yes. Something in between podzols studied by Michał, for example, albilivisols, retisols, luvisols, castanozems, and calcisols. So my questions are in some way technical. I think they are developed above or on calcareous moraines which have quite a lot of primary carbonates. How do you discriminate between primary carbonates and secondary carbonates, especially taking into account that you must quantify them? Relative abundance of primary and secondary.
Please use the mic.
Okay.
This was only one question allowed. Okay.
And
it was estimated in the stage of the field investigation. They are really very beautiful, the secondary forms of carbonates. They're so common. They are on the all of the, not all, but on the a lot of pet faces, on the stones. They also form beautiful pseudomycelium. On the roots, sometimes you can find something that previously it was the root, now the root decayed and you have beautiful secondary carbonates. So it's not a problem to distinguish. The bigger problem is to say that we had the primary. Of course, we know that in the past they had to be primary, but mostly in the field we can find a lot of secondary carbonates. So the problem is also, now we will have the article about this, that sometimes even in the stage of the field work, we just throw out some of the secondary carbonates because they are big, so we are not taking them into the estimated in the laboratory. So even the amount of the calcium carbonate can be a little underestimated in general, of course, in these samples. But yes, it was in the field. Of course, in this area, we have some micromorphological investigations. So in this case, it has no doubts about this. Thank you.
Okay, thank you both. Thanks for your contribution. And now we continue with, I say, Josef Warosewski. Is Josef? Okay, sorry about that.